So far we have learned different transformations. Basically, I say we have done with the transformations thing. So first step was to get the data importing, right? First, how we need to get the data from different sources. We understood that, and then we were able to, as soon as we get the data, we have some tasks to do, right? We have to clean the data. We have to make sure the data is good for reporting. It doesn't have null values, or at least it has structured as per our convenience. Like we split them into first name, last name, whatever. Like we remove unwanted values, we make them in a proper format, so that while we report on top of that data, we don't see any anomalies, like the data is not a correct format, the dates are not in a format like that. So we do a lot of, we spend a lot of time on this area, especially in the data transformation. And we have seen there are a lot of options to add different steps, wherein you can add new columns, we can remove unwanted columns, so we can split them, we can append, we can merge. We have seen all of those things, right? So once we build all those things in a particular report per se, so once the data is ready, let's say this data is ready, so once the entire data is ready, so what happens is basically what we are doing is we are kind of spending time in our single table, right? It's a tabular data. So we have spent a lot of time making sure each and every table is looking good. Table one, table two, table three, like that. We have bought in many queries, like if you remember sales. So yeah, let's open the report that we kind of saved it. All right. Guru schools. Okay. Let me just open that report. I think I've named it as Guru Schools, right?
Yes.
Okay. Maybe I'll just check in the folder. Kalpana is joining. So basically, what we are doing is we are kind of making sure the data is ready and all the tables are clean and neat to report on. And then comes the situation where you need to work on building data model. So why a data model is required? So basically, why a data model is required? Anybody wants to say anything about this? Why data model
Yeah,
is
we need a
required?
data model. Why? Because in order to do a proper visualization, you need a perfect data model where only the points or when only the features which the particular business needs. Like if it is healthcare industry, based on what they do on which categories, stating that few they do the hospitality, few like hospital and everything, few they do the pharmacy, few like based on their requirement. If we get a proper data model, we can do the visualization properly, and apt information will be
Mhm.
produced.
Yeah, that's a correct answer. So before yeah, that's an actual answer. But for especially for newbies, or people have no idea, like then I will come and ask you, like,
Mm.
what if I'm not what exactly is data model? Like, okay, what you said is right. What exactly is data model? Do you know what we do there?
In data model, as we discussed in our previous classes, we'll get the source, like we'll get the data from the source. After getting the data from the source, we clean up the data.
Yeah,
We'll
that's
like
the second step.
kind of transform the data,
Yeah.
and we take only the ones which we need for it, because
Mhm.
when we get the data, we'll get all sorts of information, but the information which we need for that particular data model or particular visualization will take only those columns, and then we structure our data and we do the visualization.
So there we have done with the second step. So now we are into third step of data model. So what we do in data model is, as you can see, till whatever you said is like we clean up the data and we get whatever is required. So this is where we are now. Okay, we are exactly the step that you just mentioned. So we are done with all the transformations. We have cleaned it up. We are sitting somewhere where we got all the tables in place. Okay. So now the next step that we do in the data model is basically we kind of create a relationship between the tables.
Okay.
So that is what you have to understand. So data model is nothing but creating relationship between the tables. So let us say I cleaned up the data, did all the transformations, and I bought in the tables. Now I
Mhm.
start reporting. Let's assume like I start building a table. Let's assume like there's a table that I wanted to get some information, where I wanted to see different city based, and there are a lot of cities in here. Okay, first I bought in the city column, which is coming from the city, this regions table. And then what I do is I kind of add some sales value. So I wanted to see what is the sales happening for each different city. Total revenue is nothing but our sales value. So I'll just get it. So what has happened? It seems like Auckland is
Just
doing the same, figure as all the total values is doing the same figure. Each and every city is doing the same figure.
Yeah.
Do you see some
mm,
problem with the data? Definitely, there's
it's
something.
Yeah.
auto-populated, right?
Yeah, I mean, this is work that Power BI does. It does populate, like we'll see all of that now. But again, I'm talking about the values in particular. Like, why is it the same value for all the cities? Let's go back and look at the data. Sales, yeah, I've got total revenue, different revenues, right?
Yeah.
But regions table, yes, I got region city, yeah, fine. But there seem to be something wrong. So let's understand what is happening. Okay, right. So basically, as you can see, the first before this is the tables that we have in our model right now. Customers, products.
I'm here.
Yeah, I'm just muting other people so that there's some echo coming from a different person. So yeah, I've just muted everyone. So basically, as you can see, these are the tables not connected to each other, right? And the same way, what I've done is I've just bought in total revenue for city. In this screenshot, as you can see, I bought in product name and then order quantity, total revenue, total unit cost, and everything. Like let's do it again here as well. So let's keep this table as it is. Let's bring in another table and let me have the table here, and just I will add a product. I wanted to see different products. I got product 110, like so many products. And I wanted to see each product, how many of them got sold, like order quantity. Oh, again, it's funny. All the the order quantity is same for all the products. So total revenue, yeah, the same way as total unit cost. Okay, you can see I've just added few columns in here, and you can see it doesn't give any meaningful answer like this visualizing the below columns on report. So let's understand what is exactly happening. So basically what is happening is this is just a club of few independent tables which don't have any relationship between each other, right? So we just added few tables and we did not define any relationship between them. Okay, so unless or until if you have any relationship between tables, it can't be called a proper data model. Okay, it's not a data model. Data model is nothing but a relationship between the tables. That is what is a data model. Okay, the first the basic definition of a data model is there should be a proper relationship between the tables. So I asked you a question, right? What we do is the next step in a data model. So we should say like we define some relationship between the tables. If there is more than one table, suppose let's say if there's only one table, so there is no way to define a relationship, right? So it's only the one table. But if there is more than one table and you wanted to show the relative information, when I say relative information, you can see now I try to show information from two different tables, isn't it? One from sales table, you can see the tick mark showing up from Power BI, and this product name is coming from this products table. So what I've done in this particular visual, this is a table called visual, and what we are done is we bought information from table 1, which is products table, and table 2 called sales table, and we are trying to club information from both the tables into one single table in the Power BI. So whenever you're trying to show information from multiple tables, then you will not get a meaningful information unless or until you define a relationship between them, right? So in a typical business scenario, in a typical reporting scenario, or like Malika just mentioned, right? If there is a healthcare or any other information, any other related business, uh, we do a relationship, or we try to show uh, a report. Like for example, let's say this is a table, we try to show this kind of information only if there is some relative information, right? So we don't get, like, so let's assume this is a fruits table. We get a fruits table, and we get a sales table from which has a product sales, and we don't combine them, right? We just don't get randomly a fruit and a product sales information. If there is a relative information, if it is a part of the business, only then we want to show them on the report. Just like healthcare, we want to show a related information together, right? We definitely don't want to show unrelated information. So when there is a related information that you wanted to show, there is definitely a relationship between them, where your business would have provided, or else your database team would have provided, was saying that no, these are the tables coming from this and the source, and this is how relationship it is. So your database team will provide you the information, or your business requirements or functional requirements, whoever is passing the requirements to you, they will share the details of the data sources of the tables and say these are the tables that are involved for you to build the report, and this is how it is related. As per the business, we are doing this, we are joining this, we are having these kind of columns in these tables, so we are kind of holding this information in this table A, and this information is in table B, and this is how we wanted to relate them, join them. Okay, they will give you all the information, you have no worry on that. Okay, so let's go back and understand, like, okay, so when you try to visualize the order quantity and total revenue and the total unit cost as shown in the screenshot here, you see the same value for all the rows. Okay. It is just summing up the entire value and showing it. It doesn't know that it has to filter for each product. Okay. As we didn't create any relationship, it doesn't know anything what to do. Power BI, what it is doing is it basically summing up the entire value. Let's say the order quantity, it is summing the entire order quantity. Okay, and as entire order quantity, let me just show you one more thing. I'm just creating a new visual called, this one is called card. So I'm just using that card to visualize what is my order quantity. Okay, I'm just tracking that. So you can see it's 68K, which is this. Just giving you that rough estimate. We can also change that. Uh, we can also change that the format of that. Basically, let me just click on this. Yeah, whole number. So right now it is okay, it's just giving a summation of 68K. So this is the same value. Okay, so basically what it is doing is it is basically showing the entire value. Okay, instead of dividing for one product, it's not able to divide for one product because it is not able to understand how I should filter. You didn't show me any relationship, so I don't know how to filter. That's what it is saying. Okay, so basically, if you go back to the model, or let's go back to the data and understand, right, what is there in each, table. So let's go to each table and try to understand how this is basically defined. As you can see, okay, when you click on the customers table, uh, customers names is there, which is the core information of customers table. But customer index actually was not needed, isn't it? So customers table has got the customers information, whereas index is kind of showing, what I understood is like index is a primary key. Okay. They are kind of distinguishing between, each and every key. So index will definitely always have a unique key. It's kind of a primary key. So unless or until you have a knowledge on, basic database, how usually they kind of, hold the tables like this is kind of a primary key. So what they typically do is, so what I say is, let's say, in general, like, in a like in a layman, I will ask, like, okay, I have a customer's name column here, which is the main important column from the customers table, and there is a products table. We have product name from the products table, and regions. So let's assume all other things are not needed, like city and suburb maybe are needed. Okay, we have two columns which are important. So hardly four columns are there, right? Why can't I add into a single table, right? If I add those four columns here, all this headache will be gone, right? Getting multiple tables and then relationship between them, joining them, right? All this headache is gone. You have single table, you can start reporting on that, isn't it? If I'm asking like from a layman perspective, as we can see, I got a customers table. So at least for this particular scenario, let's talk about this product name. Okay, to start in this particular table, we are only showcasing products and sales table. Okay, let's assume we just forget about customers and regions. Let's talk about products and sales table. Okay, so why are we keeping separate? So we let us keep within the same table. We'll add this product name into the same sales table, and the job will be done, right? There shouldn't be any relationship, and there's no headache of it. uh, I want you guys to think over this. I'm from a layman perspective, I'm asking you questions like, why shouldn't there be the product sitting on the sales table? Isn't it easier for us to kind of get the, if it is already, suppose let's assume just like an order number, let's just like a product description index, right? Instead of here there is a product name, so it would have been easier for us, right? Simply I would have got my product name and order quantity, and can get that. I want you guys to answer, like, because this is a core understanding of the data model. If anybody can answer, like, why shouldn't I do that? Like, why are we kind of handling a separate table for products instead of making?
As did not understand this.
Sorry.
It might be confusing or you know kind of.
Santosh, yeah. Santosh, I'm thinking like as you said, data model is like relationship between tables, isn't? When we do relationship, when you add in the same table, then it won't be any relationship, just we are merging, isn't? That's what I understood. I don't know exactly.
Yeah,
Actually.
but I also said you that if we sometimes we have only one table, and I could create proper Power BI report, not an issue. It's not always. It's
Yeah.
not a compulsory condition that you have to always have a model, always have a relationship, because sometimes you only have one table and you start creating a report.
We can make some
Yeah,
join. We can make some join.
My question, did anybody get my question? Let me just rephrase it.
Yeah.
My question is, right now I have table 1 called products, I have table 2 called sales. My question is, why should I have two tables instead of one single sale table where I have product name within it? My problem would have been solved, isn't it?
Yes,
Isn't it? You tell me. I mean, isn't it? It's so. Let's say just for let me just add a new page.
different departments, they are creating different tables. They are getting different data from different tables, different departments.
Yeah, product 1 is one department when you consider. So the same way I say there's already a product description index basically, because we know it's a properly modeled data. So when I click on products, so you can see index 1, 2, 3, 4, 20. So all these are basically coming from this. For example, I've just created a new one. Let me remove this product name from here. Okay. And let me add product description index. So don't worry about what I'm doing here. I'm just showcasing you something. So basically, this is the product 1, product 2, product 3, product 4, and you have all the products here. And can you see it is filtered the data now, which is all coming from the same table. In fact, I could replace this product description index 1 as product 1. Okay, I could do that. I could do that in my Excel sheet or whatever, the transformation data. And I could have, you can see this, I can replace them with the product names, and my job is done. Like this should have shown as product 1, product 2. And why I'm maintaining a separate products table?
One product could have so many sales. So for that product, we cannot enter that many sales in the product table.
Yeah, you're close. Yeah, that's the right answer. So basically, what is happening is, let's assume that this is a Walmart store. Okay, let's assume this is a Walmart store. Let's compare it with some Walmart store. just like, daily basis, we have a lot of sales happening here. Like every minute, every minute there are a lot of sales happening here. So in order to record all those sales, you have a sales table. Okay, this is again a database, designing. This is not a Power BI designing. So the databases are designed that way. So I'm talking about databases concepts. Don't worry. So just this is a core idea that you need to understand. That's what I'm saying. So how they are designed, databases are designed, like, this is sales information. So you say, you have done a sale order, like this is one of the sale order. You bought in so many products on a specific day. Okay. Right now, I understand this is a ship date. This means I can understand this is kind of an online store, but just forget about the ship state and let's try to correlate it with the Walmart store. Okay. So we have some sale order or maybe transaction ID. Let's maybe consider it's a transaction ID, which was done at so and so time, like, 5:30 p.m. Your time. Maybe you went to this Walmart store, you have purchased few items, and the date and the time and everything is recorded, and how much quantity you have bought, what was the price you spent, what was the total unit cost, what is the total revenue or total sales that has happened. So they're kind of storing all that information in sales table. Okay. The similar way, every transaction is being recorded. Every individual single transaction is being recorded in this particular table, which is, you can see, sale order. So your sales table is kind of, its duty is to hold only the sale information. It cannot go and record. Okay, right now Divya has done a purchase. Let's assume this particular record, Divya sales order, this particular SO 0001219 was done from Divya, but it won't record Divya's information, Divya's city, where she is coming from, which region she is coming from, which suburb she is coming from, what product she has purchased, right? What is her total name, like full name, right? All those information is not there here. It is all being recorded in the other tables. For example, let's talk about sale order, this 1219. It has got a region index 54, product description index 7, okay, and customer name index 20. So let's go one by one. So customer name index 20, let's go. If we see customer name index 20, if we go to customer's name 20, customer name index 20, if you go and look at customer index 20, Pacific Limited. So the first order was from Pacific Limited. You're getting my point? We have a relationship maintained, we have some keys maintained, so that it goes and you can go back and look into a different table, like who purchased this order, which customer. It was Pacific Limited, right? Which region? 54 region index 54. Let's go back to 54. Christchurch city, okay, 54. So from this city that order was placed. You're getting my point? So the sales information is being recorded, but basically what we are doing is we are trying to minimize in terms of the rows. We are not recording the cities, we are not recording the names. We're just maintaining the keys. We are trying to maintaining the keys, so that why we are doing is that, let's assume tomorrow, since it's an online store, we have a limited set of customers at the moment. So let's say these are 50 customers already there. Now today we have got all the 5 customers like Divya, Kalpana, Mallika, Sandhya and Swapna. We got these new 5 customers, and as a database team, I have to maintain the customers table as well, right? Because I know who are all my customers. So if I have to add 5 new customers, if I go back and add in my sales table, it makes the huge data, because for every transaction I have to maintain those new values. My data size will increase. Okay, the data size, because your sales table is kind of a transactional data. It's kind of a fact table. Okay, now the terminology comes this way. Okay, fact table, dimension table. Okay, so your customer table, whatever you see, like it's a dimension table. Your fact table is nothing but a sales table. Okay, fact table is nothing but granular data, detailed data. Okay, detailed data, like transaction information, like each and every sale, right? It goes to each and every sale that I was talking about. So it keeps on growing, because on a daily basis you might have thousands of sales. So you have your fact table keeps on going. So for every suppose Divya has to visit the Walmart store maybe 3 times a day for 4 times a day for some reason. Okay, there's a possibility, right? She might have maybe again she is visiting the store with some of her friends, and so she might be visiting the same store multiple times, and she might have done a lot of purchases. That means your sales will be recording those as sales order multiple times. Every time you done a sale, you want to add that name, place, etc. Isn't it kind of a duplicacy? Isn't it kind of a redundancy you're doing? So in a data model, I mean, in a particular database, to avoid redundancy or duplicacy, we kind of maintain this kind of separate tables, also called as normalization. People call in terms of database terminology, it's called normalization. There are separate levels of normalization. We are not going into deep of that because that's totally a database concepts. What you have to understand is why they are maintained separately, because we have to maintain that we have to avoid the duplicacy. We have to make sure our sales table is not overpopulated or overburdened with large size, because if keeping on adding the name of the customer, place of the customer in the same table, you kind of grow the size of the table to millions of records, and your report will be kind of very slow. That's where it's easier. Let's say Jim, I told you, right? Like now you have new customers, 5 customers, easily they can add the new customers. Even though they don't do any sale, that's fine. Tomorrow they might go to the Walmart store and purchase it. Then the sale will be recorded in the sales table. But I have a list of customers table intact with every time if there is new, suppose there are 100 new customers tomorrow, I can directly dump in here. I need not worry about my sales table, right? So it's easier way to handle your databases, easier way to handle your products, because tomorrow I plan to sell 20 new products in my store. I can directly add in here. That's it. I do not worry about the other tables. I can just focus on my products table and come and add it because it's a products table, right? Otherwise, what happens if you are kind of holding in the sales table? I have to make sure for every key, I have to try to maintain the product name and all that. So it's a very big headache, right? So to avoid redundancy, to avoid the duplicacy, we kind of normalize the tables. We kind of separate the tables and make sure we have different dimension tables for different area, different entity, or different information. In simple terminology, I can say different information. Let's say we have regions information. So I have a separate table for regions information. Customers, separate information is for customers. Customer table is a dimension table. Regions is a dimension table, right? And your products table is a dimension table. Okay, all these are dimension table. Okay, all these are dimension table. The fact table is only one table, which is sales table, which is having all the granular data. So one other way of identifying your fact table is your fact table will hold some information which is kind of a metric. Metric is something which can be sale, which can be amount, which can be price, which can be quantity, right? So that is one more idea that you identify if it is a fact table. So I could see there's a unit price for each sale, unit cost, total revenue. So I can look at these values and also see this table is a fact table, right? I can identify it by looking at these values and say this is also a fact table. This is one way of looking. Where you go and try to look into dimension table, you won't find those price information. Suppose you find the price information, you term it as a fact table. You don't call it as a dimension table. Dimension table is however large it is. For example, your dimension table can be large. You can say this is a dimension table. But again, there are numbers. It's not like there are no numbers. There are numbers, but it's not a price. It's just a postcode information, which is information about information, right? It's about cities information, postcode, area information, longitude and longitude and latitude. Again, it's information about information. It's kind of an area information. It's not something which I'm trying to, for example, if I go to sales, I say, if I'm talking about this first 3 sale order, I could say in my first 3 sale orders, there are total unit price. I can sum these 3 sales. I can sum these quantities like 5 plus 11 plus 9. This is 25. I can say in my first 3 sales, I've sold 25 quantity orders, 25 orders. Whereas you go to regions, I cannot sum them up. They are not summable. This is something like in my first three customers are from longitude, all this summation, I cannot sum it. This person, Auckland city is from this longitude. The Southland is from this longitude. This is a separate entity for it, right? You cannot sum it up. Even though they are numbers, my representation, my actual value, I'm not summing it up. I'm not summing the postcodes as well. Right? You're getting my point. So I'm trying to showcase that, the metrics are, I'm trying to sum it up or quantify it. Whereas these are not quantifiables, even though they are numbers. So basically, all these are dimension tables. These are all dimension tables. These are sales, these are fact tables. So now you need to have a clear understanding of what is what table, like in our data model at least, right? You can see got 4 tables, and now you clearly understand which table is what. Like what is your fact table, what is your dimension table, and what exactly is a dimension table. Dimension table is nothing but it has information about different areas. For example, employees table. Let's assume you have an employees table. Can anybody help me to identify employees table has got maybe 3 columns: employee ID, employee first name, employee last name. Can you please help me which table it is?
Customers.
Dimensional table.
Yeah, you need to answer me like either it is a dimension or a fact table. Okay.
Yeah.
So let me give you another example. So employee table, you column names I'm providing, like serial number, employee name, okay, employee designation. So tell me, what is again the employee table is?
Dimensional.
Dimension table.
Okay, I would say salary table, employee ID, employee salary,
Fact table.
employee
table.
bonus.
Fact.
Yeah, you're getting my point, right? You're able to
Yeah.
identify so it's all about
Yeah,
identifying it. So yeah, so it has got all the summable or quantifiable information, where our metrics we call them in our Power BI terminology. So we
So
can
will
quantify
employee
them.
ID will also be under fact table, Santosh?
No, actually, like
Employee ID should be dimensional, right? No?
Mhm. Don't we have IDs here? Can you see? Let's say customers table. Let's say customers table has got customer index. In fact, I can call it as customer ID. Okay, for easier understanding for you, customer ID. Let's see, instead of index, customer ID. Now I'll go back to my sales table. Where is my customer name index? Basically, this is also a customer in ID only. Okay. Now tell me, does my fact table doesn't have my customer ID?
Mm.
Okay, I got you. I'll clarify. Anyways, we are verge of talking about that. So just
Okay.
hold on for another 2 minutes. Your doubt will be clarified. So once
Okay.
we identify this, right? Once you are able to identify, now you got the clear picture. Okay, these are the dimension tables. These are the fact tables. Cool. Now you're
Okay.
good. So in a typical database model, then how they are kind of maintaining them, right? So they have to maintain them. Just storing information in a separate products table, in a separate sales table is not enough. When you hold a products table, there should be a related information, just like I told you, right? So there's a product description index, which is again an index. So I told you there's a dimension table. As you can see, your dimension table, if you go to the products table, this is an index or a product ID. You could call it as a product ID to make it your concepts clear. Okay. So product ID, again, it's kind of an unique key, isn't it? So unique key is a primary key in your dimension table. So we are trying to maintain primary keys in our dimension tables. Okay. One more thing, the primary keys in our dimension tables, because we need to identify these product names with these keys from other tables, like from other tables in the sense, especially the sales table. Just like, okay, separate, holding it separately is fine, but what is the use of if it is not helping us, right? We have to hold them separately, again, in order to make sure our sale order information can be pulled whenever it is needed. Suppose, let's assume you are not having these keys here. Even though you maintain a fact table separately and a product table separately, it's not helping you anyways. You're thinking like, okay, I'm intelligent. I'm not increasing my size of my model or my size of my table. I'm holding my product information separately. I'm very much intelligent. But what is the use of that unless or until that information that you're storing is not able to help you to make some decisions, right? This information on a future, your store manager, like your Walmart store manager, he has to sit down on a weekly basis and see, okay, last week, who has come, like how many sales has happened, how many products have sold, how many products have sold, on a large large quantity wise. So all those insights or all those decision making things, if he is not able to make, then it's no use. When he will be able to make, when he is able to understand, okay, this sale order, is it coming from which customer or which region? If you're not holding this region index or customer ID, he doesn't know if it is that is coming from Divya, is coming from California, like that person is coming from that particular Seattle or whatever place, right? You cannot make any decision. Then what is the use of holding this data? So that's where in your database normalization, the second part that they do is they divide the tables, they separate the tables. The same time in the normalization, there's another concept called within the normalization, they make sure they create some keys, okay, called as primary keys, foreign keys. Okay, this is again a database modeling, a normalization concept. So they do the normalization by making sure your dimension table has got a primary key, because your dimension table should be unique, right? The purpose of dimension table was to avoid the repetitiveness or redundancy or the duplicacy. Then you don't have two customer IDs, one, right? Two customer names repeated. The purpose was to avoid the duplicacy, because your sales table was already duplicated, because the same person could have ordered multiple times, right? For example, you can see the product description index 7. All these are 777. That means the product 7 has been sold multiple times. The same product has been bought multiple times, right? So you cannot add the repeated values there. So that's where your product has to be unique. Product 7 is unique. So here you hold the primary key to avoid the duplicacy. Okay. You create a primary key, right? And then there is a foreign key. What is a foreign key? If you talk about your dimension table has got a primary key. The foreign key is sitting in the foreign table called sales table. So foreign key is something, for example, for a product, let me rename it. Product ID. Okay. The same thing as this products table has got your primary key in this dimension table called product table has got product ID as your primary key, and your sales table has got the foreign key for the same product ID. You're getting my point. Here it can be repeated. The purpose is fine. Since it's in numbers, so although somebody can say, boss, you're saying adding product name would add up, increase the size of the data or increase the redundancy. But again, you're doing the same thing indirectly. You're adding a number instead of product ID, name or region names and all. You're adding a number. But in databases, numbers are the fast way of retrieving. Keys are the fast ways of retrieving, right? Indexing, it does a lot of indexing. So numbers is a very fast way of retrieving. So it is fine if we can store it in terms of keys. And I'm not storing like too many keys. For example, let's talk about regions table. I have got 1, 2, 3, 4, 5, 6 columns here. But all these 6 column information can be just bought in easily by one index, right? One particular index. Like if I go back to my sales table and look at my region index, right? Region index 2. I can, with one single 2, I can go back and get these values of Nightcap, Southland, all this. All this information like Line Street. So I can have a big table also from dimension table, if it is a proper information, right? Sometimes you have a information about customer, like customer social security number, customer place, customer date of birth, customer, where is from coming from, studies, age. It can grow. It can be huge dimension table. But I'm intelligently storing one index and its corresponding index in the sales table as one key itself. You're getting my point? Because somebody would have asked this question. That's why I've answered this. Because this key does a purpose. So right now, as you can see, product ID is a foreign key in our fact table. And here it's a primary key in our dimension table. So now that you have understood, let's go back. Let's go back and see. Okay, let's try to create the relationships now. Okay. So what I do is, as you can see, let me just start the relation. I know product ID can be joined with my product ID sales. So there is one more thing I will be talking about, especially about Power BI. Okay, let me just keep it region. So what I'll do is, let me go to data view first. I'll try to kind of rename so that you guys are kind of, I would say, region ID. It's easier way of understanding. It will remove your confusion. So I'd say region ID, product ID, customer ID, spelling mistake. Region ID, product ID, customer ID. Okay, I've done that. So let's go back to our. So what I'm doing is, I'm just joining. Like, I'm just dragging and dropping. Just forget about all those. I'll show you how we can join. Customer ID, join. Where is the customer ID? Yes, there is. And regions. Region ID. I'm just dragging and dropping. It's easy way of creating your joins. There's another method also. I'll talk about that. Okay. So now, as you can see, I've just made a relationship. And do you want to check the data after defining the relationship? What has happened to our previously created visuals? Did you see any difference?
Oh yeah, the number has been changed.
Yeah.
Do you think it is kind of showing the meaningful information now?
Yes.
Right. Yes.
So not only that, let me just delete this product ID. Okay. And we were supposed to get our product ID from here, product name from here, right? Yeah. Go back to page one also. Yeah. Can you see the city?
Yeah.
Yeah.
Yes. Yes.
Yeah. So now it knows, boss, I understand where to go now. How to filter my data specifically and give you the correct values. Okay. Don't worry about how it is filtering and all. I'm going to talk about all that. Okay. So in Power BI, right? In Power BI, one thing you need to make sure is Power BI is, so there are a lot of data models. There are different concepts of data models. Okay. There is, different schemas. We call it as schemas. So when you create a relationship and the tables are in the structure, we call it a schema. So for example, star schema, Snowflake schema, like that. Okay. So right now in a Power BI, mostly we do the star schema. First one. Okay. Star schema. Power BI engine is, it works very efficiently when you have a star schema. Okay, this one. Star schema. So what is a star schema? Star schema definition wise, it is keeping your fact table in the center and joining, having the dimension tables around it. That is what is star schema. Around it means just keeping it around it is not required. You have to join them. Okay. I'm saying the relationship, after relationship, your fact table should be at the center, right? Right now, what I've done, this is my fact table. My fact table is at the center and the dimension tables are surrounded on top of it. Okay. This is what is star schema. So you should always keep your fact table on the center and the dimensions around it. That is what is your star schema. So your Power BI engine mainly drives on basis of star schema, and at maximum times you have to go with the star schema where your fact table is at the center and the dimension tables around it. And in the very advanced concepts, there would be a little bit of addition of new more tables like Snowflake schema. Snowflake schema is nothing but, for example, this regions table could have gone to the next level of dividing. For example, let's say city and region ID we have, and suburb, longitude, latitude, postcode could have been in a next table, region subtable, and that could have joined to this table. Okay, that means your region 2 table has joined to region 1 table, and then region 1 table has joined to your sales table. So that is becoming your Snowflake model, which is rarely used. Okay, right now your focus should be on this model, star schema. Okay, the star schema is the one which drives the Power BI, which does the job very well. So what happens in a star schema? Like we, as you see, we have joined this products table. So we do the join again. We'll delete this, right click. Yes, I want to delete the relationship because I wanted to see what is happening and how to join. I've shown you easier way to join, drag and drop. And second way is to join from here on the top. As you can see, we are in the data model and you wanted to click on manage relationships. And let's assume you wanted to create a new join, new relationship. Yes, I want to form a new relationship. Click on new. Okay, select tables and columns that are related. So I want to create a relationship between my fact table first, like sales table. Let me keep the sales table first. And I wanted to create the first relationship between the sales table and the products table. Click on the products table. So, okay, boss, you're saying you want to create a relationship. So tell me, what are the columns that are involved in that relationship? Yes, I'm aware of that. I wanted to join product ID and the product ID. I have to select this one. Product ID from the sales table, product ID from the products table. Okay, cool. So automatically what happens is there's something called cardinality. When you click on this, automatically there is cardinality defined. Okay, automatically the cardinality is defined. Okay, there are multiple cardinalities. So what exactly is cardinality? Cardinality is nothing but the way you are joining, like the way you are joining between two tables, or the way the data is related between the two tables. Okay, so basically, especially in the definition, well, let me just talk about it here. So cardinality is nothing but the distinct values in a particular column. So one value of each primary key has many values of each foreign key. Right now, the same thing we are doing, right? Sales table and the products table. So product ID from the sales table and the product ID from the products table, you can see what we are doing is, you can see here, the type is many to one. That means one value of each primary key. That means, do you know primary key, how many values you have? This is a primary key from the products table. How many values you have here? This products table is a dimension table, and it has got a primary key called product ID. Primary key is supposed to have a unique value that you are already aware of it, right? That means your product ID is having unique values, right? That means you can see many to one relationship. That means many is sales. That means you already can see the 7 is repeated. That means you have many values in the sales table for the product ID and the single value in the products table. Many to one relationship. You're getting the point. You're getting the point. When you click on it, okay, let's close it. Just click on it, okay. You can see one too many. That means what it is trying to say is, boss, primary key is having one single value, whereas you got multiple product IDs. Multiple product IDs. Right? You can go back and look at the data to make it more clear. We're talking about product ID. You can see 7, how many times it is repeated. Although uniquely we have 14 unique values, but each sale or each product has been purchased more number of times, isn't
Many
it?
times.
Obviously.
So you mean to say product is 1 and N is sales? Why? Because one product can be sold many times.
Exactly. 1 to N. It's kind of a 1 to N relationship. 1 to N. N can be many, right? 1 to N or 1 to many. Yeah.
Okay.
So this is what is automatically, cardinality will sometimes automatically be detected. Even though you try to define it wrongly, sometimes it will throw an error. You can see I defined it the either way, 1 to many. This is the candidate result isn't valid for this relationship because I'm a Power BI tool. I can scan the data and I can understand. You are trying to fool me, saying that, it's wrong. So basically, this is the right one. Yeah. So basically, cardinality can be like this. So sometimes you have many to one to many to one, either way. 1 to 1. Sometimes you have 1 to 1 relationship, and sometimes you have many to many relationship. So this is not suggested to use many to many. You end up getting wrong results. Yeah. Sometimes you have 1 to 1 depending on the data. So you're not right now. You don't worry about all that. Your focus should be on this many to one. Okay. And there is something called cross filter direction. We'll be talking about it little later. Okay, just forget about it. And this is how you have to join. Now you have something region stable. So can you want to go easier way? You can just drag and drop. What has happened automatically? One to many has been defined, isn't it?
Okay.
This is
Yeah.
one. Now I want to go the difficult way. Let me just click on manage relationships. Now create a join between customers table now. Sales and customers. Customer ID and customer ID. This is many. This is let's say customer table. I'll bring it first. Sales second. So what has happened? One to many. Isn't it the other way? Either way, it's the same thing. Like wherever is the many, it will show that way. That said many. Okay.
I hope we'll follow the easier one.
Yeah.
It's much better.
Initially, when we don't know, right, it is good to drag and drop. Once you get
Yeah.
familiarized
Yeah.
with the system, we can do that managed.
Exactly. So you just check it out because see, everything is it's practice. Just it's nothing super science. Because suppose somebody is trying to learn photo editing. Okay, he wants to learn Adobe Photoshop. Right? There are so many versions of it, Adobe Photoshop. So he'll try to go with the latest version, and he tries to understand the UI options. And once he learns some options, he wanted to use that option multiple times. Only he gets a hands-on on that, right? Practicals will become more, it makes him perfect. Same way, just like any other tool. If you practicing, okay, you use this screen many a times, then you close your eyes and you click on here like that. That much. It's all about practice. It's all about how many times you got exposed to that particular screen, right? That's it. The difference between you and me is that I've exposed to these options many a times. That's it.
Right.
Nothing much difference. Okay.
Mm.
So I'm exposed to the screen many a times. Maybe it's just like a movie. You might have, somebody might have watched it more times. They know what happens next. And somebody is watching for the first or second time. That's it. That's the only difference. Okay. You just try to open the tool, repeat my whatever I have taught, repeat it. You'll get some doubts. Ask me. First stick to the training. Once it is done, just explore outside. Keep learning, because even today I'm keeping on myself updated. Today I'm learning many things. Today I'm facing many challenges, many complex situations, many things. Especially if you saw about the data, I mean, I'm working with one of the students, right? So we're seeing a lot of different anomalies in the tool. We sometimes the data, even though the formula is correct, the data is not, because maybe sometimes there is some bug in the tool. Sometimes there's some other issue that we are trying to understand, explore, right? There's a lot of analysis, a lot of work you keep doing. So not only you and me, every analyst out there is doing the same thing. But some analysts are little ahead, some analysts are little behind, right? Even though the people who are ahead, right, they have their own new challenges that they are working on. Okay. Don't underestimate that you are just beginning. I do not know anything. Nothing like that. You just the time. Just you do the practice. You will be the next level. Likewise, you right now you can correlate yourself where you are at the moment. You started importing the data. You've seen like how to import the data from SharePoint, OData, IMDb, and then you know how to transformations, like do the transformations. Now you are at the data model. Didn't you learn so many things? So this like tomorrow you start working on the report. So you have to make sure all these are practiced regularly so that you be strong on these concepts. That's it. Okay. So you will be learning it, not an issue. It's easier way. So what you are seeing at the moment at the screen is I'm just structuring like fact table is at the center. I'm trying to make sure it is kind of looking like a star. Just I'm doing it purposefully.
Yeah, Santosh, I have a question here. You are saying star table, and and like according to the definition, you are saying the fact table should be in the center and it is surrounded by. Is it like definitely we have to keep the fact table in the center and do it, or just it's
No,
like
no,
a
you can keep
saying?
it like this. Okay.
Oh, okay. No, I was like,
That's what I said. You can keep it like this.
Yeah. Okay.
Okay,
Thank you.
you can throw it fact table somewhere in the corners. Doesn't
No,
matter.
like, see, the
Yeah.
definition made me like, okay,
Yeah,
do I see
just for
that?
easier way of understanding, people,
No, you are saying in a layman language for
yeah.
us to
So
understand
people
initially. Got it.
learn this way because people who wants to jumpstart learning. So this is how the learning will be faster. So
Okay.
okay, star schema, okay, star model, okay, done. So they quickly we will learn it. But if you sit back and question, yeah, there is a lot of answers that you keep getting. So that's a good way. It's not. I mean, this is a good way to ask questions. Yeah, that will again make you more clarity, get you more clarity. That's good. But yeah, this usually we the way people explain to understand the concepts, they kind of use these kind of ints or language scenarios. So because human psychology is meant for learning faster or remember something, when they give some examples of this. So star schema, the name itself, the star schema is given because the concept was something like the fact table is the center kind of a thing.
Even when we look model relationships,
Yeah.
easily we can identify, oh, this is the
Yeah.
foreign key table. There's a
Identify.
reason, like we can put foreign key tables top and down, all dimension
Yeah.
tables also. We can go anywhere either. Like.
Exactly. That's right, Kalpana. Yeah. So easier way to for on our eyes also. Yeah. So this is all about star schema, and finally we were able to create relationship. Only because of that we were able to see the proper information here. Somehow the information that we are showcasing in the very first table, if you see, initially city wise the total revenue was showing all the crap information, but now it is showing some meaningful information. So let's basically understand. Okay. Yeah.
Santosh, one quick question.
Mhm.
So can a table have two primary keys?
Well, what is the definition of a primary key?
I mean, it should be unique. Unique values should be there in
Yeah.
a table.
So
So
if
what
you have
if
a
we have
unique,
two unique?
yeah, when you say unique value here, indirectly even the customer name is also unique. Indirectly, I can say the customer name is also kind of a unique key.
Right.
It could be
Yeah.
a primary key. That means you can have a multiple primary unique keys, right? Because customer name, let's add a social security number to it. Okay, next column. So
Yeah, that's what
definitely
my
for each customer has a so definitely unique key, unique. We can have multiple primary keys. Not an
Okay.
issue.
Divya,
Okay.
for your question, right? Primary key, if we, I mean, like we have to identify one which is really unique. Even for names, we cannot take that as a unique one. Why?
Yeah,
Because the
exactly.
names
Names
might
cannot be
repeat.
taken as unique. Yeah,
Names
No,
absolutely.
might repeat,
okay, let
right?
me pick you example. Say same example. What I thought was we have a employee ID, employee name, and the SSN number. So
Okay.
in this scenario, we can't consider name as a unique value,
Exactly.
whereas we can consider ID and
As
the
is.
SSN number as a
So
unique value.
SSN will be the unique one. Why? Because SSN won't repeat.
Even ID
ID
is
will
a
also
unique
be
one.
repeat.
Even
Yeah.
ID
Even
is a
ID
unique
is
one.
unique, but if I handle that data, I'll take the SSN one. Why? Because it's
Because it
pretty unique.
depends,
No, no,
Malika.
I'm
It
just
depends. Yeah,
asking.
yeah, yeah.
Yeah.
It
Yeah,
depends.
yeah.
One example there. It depends. For example, you have a sales table which has got a employee ID. Let's assume employee ID here. So you, by closing eyes, you will take the employee ID instead of SSN number. But
Yeah.
let's assume you bought in a new table for whatever reason. Maybe your manager has given you some table which has got SSN number, and that table has got SSN information, customer information, but doesn't have an ID. So that time you
Then
could
SSN.
use, yeah, you can join SSN to join this.
SSN.
Yeah.
Yeah.
So it depends on situation. Like from initially I was telling, right? Depends upon the
Yeah.
situation and the requirements that you get. It's not like standardized rule. It depends. It's all about like, I showed you how to split the data. I can split into various ways. Same way, it's all your option or your scenario, your management or your work that has come up. You
Yeah,
can
it
manage
may be
your
you say like
creativity.
based on the requirement provided by
Yeah,
the.
it's your creativity. Okay.
Okay.
Yeah. So before, because first I want you to digest this part, because tomorrow I'm going to add on couple of more, flavor to it and close data model. Flavor in the sense understanding filter flow and active and inactive relationships. So I'll talk about that tomorrow. So today, I think this is fair enough, and tomorrow I'll be talking about like what is an active relationship and what is inactive relationship. This is something like at any given point of time you should have only one relationship, just like boyfriend and girlfriend. So you cannot have multiple relationship at the same time. So something like that. So we will talk about that tomorrow.
Whole table will be filled.
Yeah. Yeah. Yeah.
That's a good example.
Yeah. So
We have
just,
something.
yeah, you have any
Uh,
questions?
Yeah, I have question and Swapna.
Tell
See,
me.
what I understood from today's class is,
Mhm.
first of all, as a to use this tool or to do anything in that, first we need to understand the data. That is the most,
Exactly.
Yeah. Yeah.
is the
Exactly,
vital.
Sapna. Core point.
Yeah.
Yeah. Without having knowledge of data, you cannot even start your
Create.
work. First,
Right.
any requirement is given, any project, whatever, sit down calmly. See, okay, what is my data? What is my source? Okay, what are the columns involved? What is it actually? Is it a movie related data which has movie names, year of the release or something like? Then you understand. Okay, I have the year release, and separate table also has got a rating table which has got years. I can join this, something like that. You can come up with some creativity, some analysis where you can correlate two tables, multiple tables, right? Understanding of data
Yeah.
is very, very important.
Okay. Understood.
Yeah. Any more questions before I wrap up today?
As of now,
No,
no.
maybe
Yeah,
after
because
we
yeah,
practice
this is a
it.
new concept. You need to understand this, because your entire report will rely on this. Because only after you have seen this, right? I've given an example. Your data was not coming properly, but when I given a proper relationship, it has fixed automatically. Yeah. So we'll talk about multiple things. Like there are a lot of other things involved.
One more, Santosh.
Mhm.
First, in the starting, we did some, you see, it automatically created some relationship between the tables, right? But
Yeah.
we choose not to opt that tables. If we choose that automatic relationships, it creates the same relationship or not?
No. It will not, because it might have a different idea. So it's always
Oh,
advisable not to go with that, because again, even if you go with that, you have to put your mind, because data model is something which you have to define. Because it's just like the same answer you have given. Data model is something that you have understood your data, and you know how to give relationship between the data. Like, just like uh, you are trying to marry someone, and just like boyfriend girlfriend relationship, so you wanted to maintain relationship with someone who you know better, and you kind of make that relationship works or not, something like that. You kind of make sure you're defining the proper relationships. And if you're automatically, you're just fluking, like, just like we go to some different sites, and we'll get new people, the relationship might not work, because automatic relationship, we don't know anything about them, we don't understand any data, right? So
good.
just like understanding the keys, understanding what if the keys are having unique values, does the key is having a foreign key in the fact table? Okay, can I match it? Can I? Sometimes we have to filter the data and see, does it has really have the data properly in the number format, or it has a text? Do I need to change them? So a lot of work is there before we actually go and join.
Got it. Thank you.
Okay. All right, guys, and we'll catch up in the next session. I want you to go through this session. Okay, I'll try to get the video early. All right, so go through the video and just make sure by next session you understood that, because this is a core again. As we go on, we get like these few things. Okay.
Okay.
Is it interesting, by the way?
Yeah.
Yeah, really very interesting.
Very interesting. And
Okay.
You
Good.
say,
because
you
it's
say, I can play with data. It's kind of like that only. It's kind
Kind of, yeah.
I
Yeah.
think with the data we need to play a lot, even
Yeah.
because more I